So oftentimes you're given a summary of how different categories can overlap. For instance, when you're comparing results from experiments, surveys, or even feature usage, and you just asked to visualize this, a Venn diagram might be your best resort because it really helps you see your intersections a lot more clearly. Now, before I really go into details about pairwise Venn or triple Venn, just a head start, I already have my library Venn diagram up and running. And make sure you run these 2 lines of code just so you have it all good to go. So ls package, upon running it on your console, you might be able to see all these. It's nothing but just your functions, all the functions that the package really consists of. Now, feel free to use other libraries or packages here on R. You can go for ggwen if you have used ggplot before. So you can use ggwen, Venn detail, or Euler. Either one's work. And this is just going to be a review where I am going to be using Venn diagram this time. Pairwise Venn diagram is just going to compare 2 sets. So this just applies to when you're dealing with 2 of these cases. So if we were to consider a small experiment testing 2 sensors. So sensor A is going to detect heat, sensor B is going to detect motion. Out of 80 total trials, sensor A gets triggered 45 times and sensor B gets triggered around 50 times. And both your sensors gets triggered around 20 times. Now, feel free to do your little calculations in your head just to see how this is going to turn out. Yeah, so let's get going with the visualization. So if you're new to using any of these libraries or packages, I would highly suggest you look into the R documentation module where it's going to really help you figure a few things out. If not, looking forward to dive deeper, feel free to scroll through. So I'm going to go with draw pairwise.when, or you could just even hover about. You can see the syntax here. So you can see area 1, area 2, cross area, category. These are the fundamental arguments that you use for this function. So my area 1 is going to be 45 because 45 is the amount of times my sensor A got triggered, or your set A, if I would say. And area 2 is going to be 50. 50 is going to be the amount of times sensor B gets triggered, and cross dot area, and that's just going to be nothing but your A intersection B, or A intersects B, which is going to be 20. Remember, it's already mentioned in the question, right? So it's going to be 20. Now comes all the organizing part. Aesthetics, whatever you may want to do, feel free to do it here. So I'm going to keep it really generic. I'm going to go with categories. I'm going to just label my sets. So let's go with sensor A and sensor B. Please be mindful of the little syntax errors that may arise. R is pretty sensitive with cases and commas here, so just be a little mindful about that. And we have fill. Fill, this argument is just going to help you assign a color to your diagrams. So I'm just going to go with blue, okay, never mind, sea blue, and beige. I'll run that. And that's it. You get your pairwise Venn, showing where both the sensors intersect and where they're independent. Now, if you find yourself stuck or confused with how area 1 or area 2 that you just mentioned here in your function translates into this diagram, feel free to skip a few parts from this review, and you can really find me going deep about how the function really maps out, right? So I really do go into details about how to identify sets and how do they really work and the calculations behind it. For Venn diagrams, this is just going to compare 3 sets. So if you really want to show how 3 groups overlap, this is where it is. Now, similar questions are noticed for your labs and your work modules. So feel free to go with any of the ones that you want to really go ahead with. Now, Let's consider a survey where 120 researchers were asked about the simulation tools that they use. Now,
65 of them use MATLAB and 50 use Python. 40 of them use Simulink and 25 use both MATLAB and Python. 15 use Python and Simulink and 20 use MATLAB and Simulink, and 10 of them use all three together.
First things first, it's always a great practice to actually go through your R documentation if you're new to any functions. Now, this function is quite similar to Pairwise. And why I say so is because, remember how I mentioned similar, but not exactly it? Well, for Pairwise, all you did was you just enter area 1, area 2, and cross dot area. And you were just basically comparing two sets. You were just playing around with two sets. So your cross dot area is going to be your pairwise or intersection, A intersects B. Now, for triple Venn, you are going to specify
an extra set.
And you are going to specify each pairs, aka pairwise of each of the areas. Now, and 1, 2, 3 is just going to be your overlap, where all three sets or all three groups meet. Now, this is a very direct question, so we'll do this as we go. So I'm going to begin with draw dot triple. First things first, I'm going to fill out my area 1, area 2, all the way until area 3. Now, these are going to be my first three areas. MATLAB is going to be my area 1, area 2 is going to be Python, area 3 is going to be Simulink. Now, I'm just going to fill these up. Right. So my N12 is going to be my intersection of area 1 and area 2. Now, it's already given the question, 25 of them use both MATLAB and Python, which is going to be 25. And my N23 is going to be 15. And N23, N13 actually. Yeah, N13 is going to be 20. And my N123 is going to be 10. I'm going to go with this argument to label my sets. And just going to give another one. And that's how your triple Venn diagram looks like. You can really make out each of your sets clearly now, which is going to be the pink, that's for Python, and the gray, so the circle. So each circle is a set, right? So it's going to be set MATLAB, set Python, and set Simulink. And each of these. So you have pairs with each of these sets, all distinct. Now, this is going to be your N12 and your N23 and your N13. And that's going to be with your N123, which is going to be your intersection. And that's how we create both pairwise and triple Venn diagrams in RStudio.